All right, here we go. This is one of the best lessons of the year. It's the quadratic formula. So I want to make sure we understand why we're doing this and why it's so much fun. This is what we've done the last couple of weeks. This is a long video. I apologize for, but it's necessary. First, we've learned how to find the solutions for a quadratic by graphing. Where is the line? Where's the parabola across the x-axis? We also spent some time on factoring. That's probably the easiest one. If you can factor a trinomial, you can find the two zeros. This last week, we did square roots, which a lot of you liked, and you did pretty darn well on that one. If we can get our x, we can use square roots to also find the values. The question, though, today is what if they don't work? Okay, what if they don't work? Okay, sometimes they won't. So let's go back to why we're doing this. The difference between a function and an equation. If you remember functions, the fun in functions. Function is when you have a y equals you have a y and an x. Function is input. If you have an x value, you can get the y. You put in an x, you get a y. An equation is when we only have one variable. We're solving for x basically. That's over here. It's the same format. We do that in quadratic equation because what we're looking for is where does the line cross the x-axis, which means the y value is 0. So the y value is 0, then we put in the x. That's where it crosses the parabola. That's why we make the y a 0. So we can find the ordered pair where the line crosses. So this is what we've been able to, so the solutions are 2 and 8. What is on the rest of this slide? So that's an example of what we're looking for. The input is the output function. We find an x, we get the y. On the equation, we know what the y already is. We want it to be 0. Therefore, we put that in, and we can get the function. The solutions here are 2 and 8. On the quadratic of the ordered pair, the y value is 0, the x is 2 for that one. The y value is 0, the x is 8 for that one. That's why we're doing all this. So in order we remember that. So there's your function on the left and your equation on the right. So there's an example of it with the constants put it with an a, b, and a c. A is 1, b is 3, c is negative 18. So there's a quadratic function, y equals x squared plus 3x minus 18. We want to find the ordered pair, we make that equal 0. Now we want to find the x. So really what we're doing, can we solve an equation for x? Normally that's easy, but the reason quadratics is harder is because of this term here, because that variable x is squared. So in order to get x by itself, at some point, we need to use the square root. That's why factoring worked out well and why using square roots worked out well. That's why graphing wasn't as fun. So that's why we are doing all this. And that's why it's much harder with quadratics, because the x value at one point is being squared. So you know how to graph. You didn't like graphing, and I understand that. It's kind of tedious, but you can graph, putting in x, get a y, and find out where the parabola crosses. You can factor it, and actually this is factorable. Negative 18, and look at the c value, look at the b value. Factors of negative 18, whose sum is 3, and we can figure that out. It happens to be 6 and 3. X plus 6, x minus 3. So we could find pretty easily that the solution for this would be negative 6 and 3. The square root we did last week. Sometimes you might get a quadratic that might look like that. X squared minus 18. Well, you want the y to be 0, so you set the y to be, make y 0. Then we add 18 to both sides. You can take the square root of that, and you can get the values to be the square root of, or x could equal the positive value of root 18 and the negative value of root 18. Of course, we could simplify that to 3 roots 2, I believe, but that is a square root, relatively simple. Well, what do we do? Question mark, question mark. What if we can't do any of those? Look at that formula there. 2x squared minus 5x plus 3. You cannot find the perfect square roots. You can't find, it's not factorable. So what do we do then? Graphing is just a pain. This is what we can do. That blue dot. So there's a formula. If only we could get x by itself. If we could get x by itself, that's what we want to do. So how can we do that here? Well, somebody figured it out. Watch this. I love this little thing. Normally I do this for like 25 minutes in class. I'm going to kind of go through this. How can we turn this so x is by itself by doing our algebra? This is what people figured out. Each step, they multiplied both sides by 4a. That stayed 0. They made that. Why did they do that? That's nothing worse. Same value, just multiply both sides by 4a. Then they decided to add b to the b squared to both sides. I forgot that. There's 2 right there. Add a b squared to both sides. Plus b squared plus b squared. Not changing the value. Then they subtract this 4ac from both sides. They subtracted it from there and put it over there. Here's the hard part. I don't know why they figured this out, but at this point, believe it or not, this trinomial is a perfect square, so they found the square root of it. 2ax plus b parentheses squared still equals that. They find the square root of both sides. You get that. This is looking complicated, but this is where we're headed. So you have 2ax plus b equals plus or minus square root of b squared minus 4ac. Then they subtract b from both sides to make it negative b plus or minus the square root of b squared minus 4ac. Then they get x by itself. One more step. They divided everything by 2a. And that, boys and girls, ladies and gentlemen, anybody who's watching, that is the quadratic formula. They're able to take the quadratic equation and get x by itself. So now, if you can't factor it, if you can't find square roots, we can have a formula to get the x by itself. It looks complicated, and it can be, but it will work for any quadratic formula. All right, so that's what we're doing this week. There's a lot of videos. This is kind of a longer one. Where am I right now? I don't have my glasses on. It's probably too long already. I want to show you what we're going to do. So there is the quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and that's our main thing this week. We're at 3 examples already taped for you. This is the introduction. I've got 2 more little ones to help you memorize this and to talk about the hardest part is under that square root sign. We're going to talk about that more in detail. So here's a quick example of how it works. There is a quadratic formula, not factorable at all. So we're going to plug in, there's the quadratic formula. We're going to plug in the a, b, and c values. A is 2, b is negative 5, c is 3. You plug those in, and you get this. This is one of those things, you got to write them out. Negative 5, take a look at that. When we simplify, that's going to be 5. This happens to be a square root of negative 5 squared is 25. 4 times 2 is 3 is 24. Square root of 1 over 4. So actually, it went pretty ugly to kind of compact pretty quickly. The square root of 1 is 1. So you end up with 5 plus or minus 1 over 4. And there's 2 of those, a 5 plus 1 and a 5 minus 1. And there are your solutions. 5 plus 1 over 4, 5 minus 1 over 4. For negative 3 halves, or is it 3 halves? I can't read that very well. I think it's 3 halves. Yes, 3 halves. Looks fine. It's 3 halves and 1, negative 1. That's 1. That's 1. 4 over 4. So that's the quadratic formula. And we're going to spend all week on this. It's the highlight of algebra. So that's our first introduction. And I'm going to put these videos kind of in order as you watch them. So I'll stop that for now, and you're ready to roll on quadratic formula.